let me show you guys one and let's talk about it. I'm going to show Ava's and Marley's. Okay. Okay, so notice how she has, so that she has 1 here because length times the width. 1 times 1 is 1. And then 1 times 1 times 6 because it's length or the area of the side times how many sides there are, because remember a cube has 6 sides. So it's 6. And then the volume is 1 times 1 times 1. So it's 1. And then the surface area to volume ratio is 6 to 1 because there's 6. This is 6 and this is 1. And then the area of the side is 36, and then 216, and then it's 1 to 1 because it's the same number here. It is the same ratio to each other. And then for the last one, it's 3/5, because if you divide that out, you get 0.6, which is as simple as possible 3/5. So 3 to 5. And so what I want you guys to notice is the surface area to volume ratio and thinking about the size of the cube based on the surface area to volume ratio. And then this is Marley's. Marley's is good, but he needs to get those as simple as possible for his ratios. All right, so I'll leave Ava's up for a little while so you guys can make sure that you get those correctly put in there. Are there any questions about how we got each one? You can put it in the chat if you ever have any questions. So you're going to want to take a screenshot or write down this, probably the length of the size or the length of the side, and then the surface area to volume ratio, just so that you can kind of remember. You could also take a screenshot, that works too. Just take a picture, because we're going to talk about our results in the next couple of slides. Okay, it looks like most people are fixed theirs up, so we're going to move on. Okay, so when you look at the cube or cell in this case, when it's small, is the surface area to volume ratio large or small? And when the cube or cell is large, is the surface area large or small? Okay, think of it like a fraction, remember? So if the first one is a small cube at 1 centimeter cubed, and then its surface area to volume ratio is 6/1, which is like bigger on the left side, it's bigger, its ratio is bigger, then the smaller it is, the larger it is. Good, Ava's got it. Brandon's got it. Still need a couple of you to respond. I need one more. I'm remember, look back at your chart and look back at each of those things. As the cube gets bigger, the ratio gets okay, I'm gonna go back and show you guys on the chart. So we're looking at a small cube here. It is 1 centimeter by 1 centimeter. It is itty bitty, but its surface area to volume ratio is large because there's a little space in there, but the surface area all around it is a lot of area in comparison to what's actually inside. And then a 6 centimeter cube, which is a little bit bigger, is 1 to 1. It means the surface area on the outside equals the amount of stuff inside, the volume inside. And then as it gets even bigger, oh, now the volume inside is bigger than the surface area outside. And so the ratio is smaller because the denominator is bigger, right? Because this one right here is 6 if you divided that out. This one is 1. And this one is 0.6, so it's smaller. So let's go back to this one and let's fix some of our answers. So when the cube is small, the surface area to volume ratio is large. That's actually a slide of a plant cell you can see there on the right. And then when a cube or cell is large, the surface area to volume ratio is small. Because like that 10 centimeter cube, it has a small ratio because this stuff in the middle is there's more stuff in the middle than there is around the outside. So it's large and then small. Okay, looks like most of you fixed your answers. So I'm gonna move on. All right, so for a cell, what would the advantage be to have a small or a large surface area to volume ratio? What would be the benefit of having a large surface area to volume ratio? Why would that be a good thing? Remember what the benefit of the surface area is. Remember, the surface area is the cell membrane. So if it has more cell membrane than it does cytoplasm, why would that be beneficial? Or why might it be beneficial? Okay, keep answering. Need about one or two more of you to answer. Okay, so it is more beneficial for a cell to have a large surface area to volume ratio. And that's because, so say if your cell was really, really large, but you had a small surface area, it would be really difficult to get enough water into the cell because you don't have much surface area. And so it's hard to get the amount of water that a cell needs into the cell because you don't have enough space around it to get to regulate those things, or say to release heat. So I am 5'10", and so I'm pretty tall. My grandmother, who is 93, she is 4'10" and 85 pounds. I weigh a bit more than her because I'm 5'10". I go to her house and I'm sweating. Okay. And she's cold. She's like shivering. She's much smaller than me, so that she has more surface area to volume ratio, which means she can dissipate that heat a lot easier. So the heat can leave her body a lot easier than it can leave mine because I have more volume to my surface area. So it's a benefit to be smaller so that you can regulate easier, like your cell can regulate more easily.